তাহলে আমরা সিকোয়েন্স ইন আর এই টপিকটা নিয়ে আলোচনা করব। সিকোয়েন্স ইন আর প্রথমে আমরা যেটা জানতে চাইছি যে ডেফিনেশনটা এক্স্যাক্টলি কি হবে, হোয়াট শুড বি দ্য ডেফিনেশন অফ সিকোয়েন্স ইন আর। আজকে আমরা সিকোয়েন্স ইন আর নিয়ে আলোচনা করব। সো ফার্স্ট, ডেফিনেশন of a sequence. A sequence is a function f from n to r. So one important point, the domain of the function, domain of f, this is basically n, and codomain of f, this is exactly equals to r. So just we consider this is domain and this is codomain, and here we have a function from f from n to r. So here 1, 2, 3, 4, 5. These are the all elements in the domain. So now you will take the map f. So it will goes to f of 1, image of 1. Then this will be f of 2. In that way, we'll take the image of n, that will be fn, and so on. So we just write f suffix 1, f2 as f suffix 2, and fn as f suffix n. So in our n set we have seen f1, f2, f3 dot 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 fn, and so on. All f1, f2, f3, fn are real number, and we just write it as sequence fn, n equals to 1 to infinity. You will see in different book it is written as sequence fn, n belongs to natural number, or simply it is written as sequence fn. Now similarly, if we consider a function x from n to r, then the corresponding sequence is given by xn, n equals to 1 to infinity. That means x1, x2, xn, and so on. Where x is a function from n to r. Now, I'll give one example of a sequence, very simple example. Let xn be a sequence defined by xn equals to 1 by n for all n belongs to natural number. So then the sequence xn, that will be x1, x2, x3, and so on. So it will be 1, then a half, then 1/3. Okay. So thus I have given the definition of sequence and corresponding example. Now there are many types of sequence that we have seen. The many types of sequence are, one is important sequence is monotone sequence. So next we call the monotone sequence. We will see when a sequence is called monotone. Now the question is, when a sequence xn is called monotone sequence. Now the answer is so simple. If it is either, if a sequence xn is either monotone increasing or monotone decreasing. monotone decreasing, then the sequence XN is called a monotone sequence. Monotone sequence in R. So here it is a sequence. We can divide it in sense of monotone, monotone increasing, and another type is monotone decreasing. So now we need to know what is exactly meaning of the monotone increasing and what is exactly meaning of the monotone decreasing. Here just we draw a graph. Here in domain we take n and codomain we take r, because it is a function from n to r, a sequence. So here 1, the corresponding image is say x1, then 2, the corresponding image is x2, and so on. Here n and n plus 1, the corresponding image is xn, and for n plus 1 say xn plus 1, and so on. So this is the height corresponding to n, and this is xn, so xn and xn plus 1. Here you have seen the xn, this is less than equals to xn plus 1 for all n belongs to natural number. This is the relation holds for monotone increasing sequence. Whereas if we see this kind of sequence where just you take this is n and this is n plus 1, the height is xn and xn plus 1. Here we have seen xn greater than equals to xn plus 1 for all n belongs to natural number. This is the definition of monotone decreasing sequence. So note 1, if xn less than equals to xn plus 1 for all n belongs to natural number, then the sequence xn is called monotone increasing sequence in R. Whereas note 2, if xn greater than equals to xn plus 1 for all n belongs to natural number, then sequence xn is called monotone decreasing sequence in R. Now one common question, the common question is, what about the constant sequence? Constant sequence in R. Is it monotone increasing? Is it monotone increasing or monotone decreasing? Now we need to know what is exactly the meaning of the constant sequence first. Then we will think about its monotonicity. So constant sequence, let xn be a sequence defined by xn equals to some k for all n belongs to natural number and k is a fixed real number. Then sequence xn is called constant sequence. Constant sequence in R. Now if we think about the graph of the constant sequence xn equals to k, for all n belongs to natural number, that means x1, x2, x3 and so on, xn, all are equals to k. So here 1, 2, 3, n plus 1 and so on. So the height is basically k, so this is x1 k, x2 is also k, x3 is also k, xn is also k, xn plus 1 is also k. So it is monotone increasing as well as monotone decreasing. So the note, every constant sequence is monotone increasing as well as monotone decreasing, and hence it is a monotone sequence in R. So now the definition is monotone, that means monotone increasing or decreasing. We have given the definition of monotone increasingness and monotone decreasingness of a sequence. But again the note is, if we see the strict inequality, that means xn less than xn plus 1 for all n belongs to natural number. That implies sequence xn is strictly monotone increasing. Strictly monotone increasing sequence. In R. Whereas, if we see xn greater than xn plus 1 for all n belongs to natural number, then we can conclude the sequence xn is strictly monotone decreasing. Strictly monotone decreasing sequence. Now we need example. Example of a monotone sequence. Example 1. Let xn be a sequence defined by xn equals to n for all n belongs to natural number. And if you see the graph, 1 that means x1, that means 1, x2 2, x3 3 and so on. So that means the each member is, if we see the element of the sequence, so we see that n less than n plus 1 for all n belongs to natural number. So that means xn less than xn plus 1 for all n belongs to natural number. So that sequence xn, because since xn equals to n according to the definition of the sequence in this example, this is equals to n plus 1. So that xn is monotone increasing sequence, and in fact it is strictly monotone. It is strictly monotone increasing sequence in R. Similarly, if we take the sequence, example 2, let xn be a sequence defined by xn equals to minus n for all n belongs to natural number. Then you will see the element of the sequence are x1, that means minus 1, minus 2, minus 3, minus n plus 1 and so on. So here x1, this is minus 1, x1 minus 1, x2, so here minus 2. These are the elements. And here we see that minus n, this is greater than minus n plus 1 for all n belongs to natural number. That means xn greater than xn plus 1 for all n belongs to natural number. And hence we can conclude xn is monotone decreasing sequence. Monotone decreasing sequence. Sequence in R. So that means, in fact, we can say the sequence xn is strictly monotone decreasing. Strictly monotone decreasing sequence in R. Now we will move to the another important concept. The concept is the bounded sequence. This another important recall. Bounded sequence in R. Here the question is, when a sequence is called bounded? When a sequence xn is called bounded sequence. Answer is, if we think about each member of the sequence like this, and we can bound it between two real numbers. Between two real numbers. So these are the element of the sequence, say, and we can bound it to real number. One is here the minus k and here k. So the solution is a sequence xn is called bounded in R, bounded sequence in R, if there exists a positive real number k belongs to R such that minus k less than equals to xn less than equals to k for all n belongs to natural number. That is, if mod of xn less than equals to k for all n belongs to natural number, then the sequence is called bounded. We can define bounded sequence in the other way, that is another definition. Definition 2, a sequence xn is called bounded if there exists two real number such that small m less than equals to xn less than equals to capital M for all n belongs to natural number. Then this sequence is called bounded. So here we see the example. Let xn be a sequence defined by xn equals to 1 by n for all n belongs to natural number. So then what should be the sequence xn? This is x1, x2, x3 and so on. That means that you put n equals to 1, then half, then 1/3 and so on. Just you put on the real line. Just you take this is 0 and this is 1. So that this is x1, then half, that means x2, then 1/3, that means x3 and so on. No element exceeds 0. So we see that 0 less than xn less than equals to 1 for all n belongs to natural number, since xn equals to 1 by n. Or we can write here minus 1 less than equals to xn less than equals to 1 for all n belongs to natural number. So that means mod of xn less than equals to 1 for all n belongs to natural number. That means the sequence xn is a bounded sequence in R. We can derive many more example. Example 2, this is example 1, popular example. J sequence 1 by n, this is a bounded sequence. Another example, example 2, let xn be a sequence defined by xn equals to minus 1 whole to the power n for all n belongs to natural number. So here we see that minus 1 less than equals to xn less than equals to 1 for all n belongs to natural number. Because if n odd, then minus 1 whole to the power n equals to minus 1. And if n even, then minus 1 whole to the power n, this is equals to 1. So only two number belongs to the range of the sequence. So the xn range minus 1 to 1. So that means here we can write mod of xn less than equals to 1 for all n belongs to natural number. And hence we can conclude sequence xn, that means minus 1 whole to the power n, that sequence is bounded sequence. Bounded sequence in. Now we'll think about the convergence of the sequence. So the next recall, what should be the nature of the sequence? Nature of a sequence xn in R. So under nature of the sequence, we can say the sequence may be convergent, or we can say sequence may be divergent, or we can say sequence may be oscillates. So divergent and oscillate all together, we will say not convergent case. So if you have given a sequence x in R, so that sequence may be convergent, may be not convergent. This should be the nature of the sequence. But the case is how will justify or will conclude a sequence is convergent or not. So that comes under the convergence of a sequence. So the now question is, when a sequence xn in R is convergent in R. So we need to know about the definition. What should be the definition of a convergent sequence? A sequence xn in R is called convergent. In R and converges to some L belongs to real number. Say, if for all epsilon greater than 0, there exists a natural number k belongs to n such that mod of xn minus L less than epsilon for all n greater than equals to k. So this is the definition of the convergent, and here we say that limit n tending to infinity xn equals to L, or in some book you will see it is written as xn converges to L as n tending to infinity. So here the remark is, what is the meaning of limit n tending to infinity xn equals to L? L belongs to real number. The meaning is for all epsilon greater than 0, there exists natural number k belongs to n such that mod of xn minus L less than epsilon for all n greater than equals to k. Or we can write it as for all epsilon greater than 0, There exists K belongs to n such that L minus epsilon less than xn less than L plus epsilon for all n greater than equal to K. That means if it is real line R, that is some real number L. So here L minus epsilon, this is L plus epsilon. That means after finite terms, after kth term, all the member belongs to this interval. If this is happen, then we can conclude the sequence xn is convergent and converges to some real number L. But how will show the sequence is convergent easily? There is a steps. So a sequence xn is convergent or not? This is our question. So first step 1, you will calculate limit n tending to infinity xn. Step 2, you will see limit n tending to xn, what should be the value of the limit? The value is L and L is real number. Then step 3, our conclusion, sequence xn is convergent in R and converges to L. Just you will think about one example. You have given sequence 1 by n and you need to show that your question is so that the sequence 1 by n is convergent in R. So what I said now, you will calculate the xn equals to 1 by n for all n belongs to natural number here. If you take the sequence xn, so now you will calculate limit n tending to infinity xn. So what should be the limit? Limit n tending to infinity 1 by n. This is 0. And here L is a real number, 0 is also a real number. So that means sequence xn is convergent where? Convergent in R and converges to 0. Similarly, you have given another sequence xn equals to n plus n by n plus 1. That sequence. In similar way, you need to calculate limit n tending to infinity xn. That means limit n tending to infinity n by n plus 1. That means limit n tending to infinity 1 by 1 plus 1 by n, and this is equals to 1 and 1 is real number. So our conclusion, sequence xn is convergent and converges to 1. Here another important note, if we see limit n tending to infinity, if xn equals to L and L does not belongs to real number, that means say L either infinity or minus infinity and that does not belongs to real number, then we can conclude sequence xn is divergent or we can say not convergent. As for example, you have given a sequence xn as n. You just calculate limit n tending to infinity xn. So this will be limit n tending to infinity n. So value is infinity. This does not belongs to real number. So we can conclude sequence xn is divergent in this example. So thank you so much.